Hello students, welcome to the online class for automobile component design. This particular subject is present in your 5th semester diploma syllabus for automobile engineering department. Let me first introduce myself. My name is Tanmoy Kundu, assistant professor, Department of Automobile Engineering, Dr. Sudhir Chandra Sur, Degree Engineering College, Kolkata. Next come to the course objectives. So we have total 3 different course objectives. Next come to the course outcome. So at the end of this course, students will be able to analyze, identify these following important key points. So today, as you know that up to the last class, I have discussed the different IS different designations of engineering materials as per IS Indian standard. So as the designation part is complete, so we'll directly move towards the standards in design, that is lecture number 17. So first of all, we have to know what are design standards. So design to standard means to design items with generally accepted and uniform procedure, dimensions and materials. So generally accepted means it is accepted globally if it is an international standard, or if it is a national standard, so it must be accepted national wise. Okay, like our Indian standard. So as per the Indian standard, so every particular domain, every design procedure, design designations must be accepted throughout the India. Okay, similarly like similarly some international standards like ISO, that is International Organization for Standardization. So any part, if it is designed as per the ISO norm, so it should be accepted globally. Okay, that means worldwide. So that is the beauty of standardization, that it should be accepted and it should proceed, it should follow some same procedure, some uniform procedure, uniform dimensions and some uniform materials. Okay, so this is the procedure which is called standardization, that is the design standard. Okay, now product standardization is a technique in engineering design that aims to reduce the number of different parts within a product. Okay, like what is this, that like if you are designing any two mating parts like shaft and hole. Okay, in an assembly you are designing two components, one is shaft, one is hole. Now it is not possible to individually design and individually manufacture all those particular shaft and hole. So rather it is always advisable that the shaft and hole should be of similar size, similar kind of design, so that it can be manufactured by like mass production. Okay, so within a shortest possible period of time, a huge amount of quantity of the same design material, same same dimensional material will be produced within the shortest possible time with the help of this mass production. Okay, so this is the design standard and this is the product standard. So design standard means anything that you design, but these design norms must be accepted globally and it should follow the same procedure, same dimensions and the same materials. Okay, likewise I have discussed the product standardization. So product standardization means you have to produce the same kind of product with same dimensions, but it should be produced like in a mass production wise, so that within the shortest possible period of time a large volume of same product, same identical product can be manufactured. Okay, next, so what is the main purpose of this standardization? First of all, it makes the best practice available to everyone to use, thereby benefits in cost and time saving. So this is most important thing, that cost saving and the time saving. Okay, next, it promotes compatibility and interchangeability. So what is compatibility? Compatibility means like you are designing a shaft and you are manufacturing a hole. Okay, so in an assembly like a shaft, this is the shaft. Similar to that, you are manufacturing a hole. Okay, now this particular assembly should be made in such a way like this shaft has some manufacturing defect, so you have the other same kind of shafts, so the rejected shaft immediately will be replaced by a new shaft that is available in your inventory. Okay, so that means it is the product must be compatible enough so that the shaft shall be easily entered into the hole. Once the shaft is rejected, so another shaft will replace that particular rejected shaft. Okay, so that means it will save your time and it will save your cost. So same thing, interchangeability. So interchangeability means it is the best practice to be adopted in the mass production. Okay, so mass production, whereas in industry, any factory where there is a kind of similar like articles are manufactured in a huge scale, so the in that mass production concept we generally use that term interchangeability. Okay, next come to establish the mandatory norms for the design and production of machines so as to reduce the variations in all types, grades, and to achieve the quality characteristics from raw material to the finished product. So ultimately in any manufacturing industry, what happen, from any raw material a finished product is manufactured. Okay, so within that production chain, what happen, so we have to achieve the best quality of product. So to ensure the quality achievement, so you have to reduce the variations, like you are supposed to manufacture a shaft with the dimension like 50 millimeter, but you are manufacturing it with a variation of 2 millimeter, that is 52 millimeter. Okay, so the variations must be very much limited, and variations should be allowed like a certain proportion, like plus minus 0.1 or like this, but you cannot allow more than that. So the variations must be very much limited, so that quality wise whatever the product you are manufacturing, that should meet the customer requirement. Okay, so this is the main important purpose of all the standardizations. Next come to the generation of standards in design. So a standard is generally agreed upon set of procedures, criteria, dimensions, and materials and parts. Engineering standards may describe the dimensions and sizes of smaller parts like screw, bearing, to measure the property like fracture strength. Next, standards tell the engineers how to do the design and are usually regarded as recommendations. Okay, so starting from the very basic concept, how the standardization methodology is generated, how the basic origin of standardization method is come into the engineering field. So first of all, what is the purpose of the standard? That purpose already we have resolved. Then we have come to know that the standard should be made in such a way that it should be mutually understood or mutually prepared between a several group of industries, so that they should follow the same procedure, the same criteria, same dimension, same material, and same parts. Okay, likewise for example, for if you consider an example, like you are manufacturing a car wheel. Okay, so wheel manufacturing especially follows some criteria, some norms. Okay, now if you are manufacturing some alloy wheel, okay, so in that case the Indian standard, the AMSC standard has already given you some kind of criteria, some kind of norms, so that everyone in the world, every engineering every automobile company in the world will follow the same norm and will take the same precautions while manufacturing the alloy wheel. Okay, so that is the that are all different norms that should be accepted worldwide. So this is the procedure of standardization. So that is why the most important thing is that whatever the norms you are actually follows, that should be mutually decided by or guided by some different types of organizing institutes. Okay, so this procedure, this criteria, dimensions, materials, and parts should be mutually understood. Next, engineering standard may describe the dimensions and size of small parts like screw, bearing. So screw, bearing, these are basically small components, small parts. So their dimensions, whatever their sizes will be there. So these dimension, this sizing methodology, this design process are absolutely guided by some design norms. Okay, and to measure the property like fracture strength. So everything, every particular machine component has some failure point. So fracture point is also a failure point. So we have to come to the failure point in such a way, so that should be properly guided by, and this guidance will be controlled by the engineering standard methodology. Okay, next is that the standard tells the engineer how to do the design. That is important thing, that how you can go for the designing. That is, there are certain norms like norm number 1, norm number 2, norm 3, norm 4. So you have to follow only those important norms. Otherwise, if you follow your own norm, so it will not be accepted globally. unless perhaps you are manufacturing you are designing a vehicle body, but it is not as per the Indian standard or not as per the American standard, so it should not be accepted in India or within the America. Okay, so it should be made in such a way that in the global market it should be widely accepted. So that is why it is the basic methodology how you can design or how you can get the recommendations from the design industries. Okay, so this is the best part of standardization. The term standard and specifications are sometimes used as interchangeability. Standards refer to generalized situations where specifications refers to specialized situation. Okay, so standard, what does the standard refer? So standard refers some generalized situation. Generalized situation means some situations are there or some criteria are there which are absolutely in general. That means if these general criteria can be absolutely followed, so any industry can easily manufacture some automobile vehicle body or any other mechanical component. So these are the general guidelines. Okay, while specification, what about specification? So specification basically refers to the specialized situations, like for example like Kirloskar. So everybody knows this company Kirloskar pump. Okay, so Kirloskar is very important company which is manufacturing the pump. Now in the market there is another company like WPIL, Worthington Pump India Limited. This company is also manufacturing pump. Now if you are considering a pump like centrifugal pump, so this centrifugal pump is manufactured by Kirloskar as well as WPIL. So Kirloskar and WPIL will follow the same generalized situation that are called the standard. So the standard adopted by Kirloskar and WPIL to manufacture the pump is the same. But what about the specification? The pump specification may be varied manufacturer to manufacturer. Like a particular case, the centrifugal pump manufactured by the Kirloskar pump will be certainly follow a specific specifications. Okay, but WPL may follow a different types of specific design guidelines. Okay, so these specifications, these technical specification must vary as per the designer or as per the manufacturer itself, but the whatever the standards are followed by all the manufacturer, that should be the uniform and that should be the identical as per the worldwide norms, that is the design standard. Okay, along with standard, codes are followed in design. So one important term with standard that is used, code. Okay, code means like we have different codes like IS, Indian standard codes. Okay, certainly codes are there like IS 8085. Okay, certain codes are there are IS 3589. These are the piping codes. Okay, that you don't know, but I am telling you. So these are the different codes within the IS standard. Okay, so codes are basically followed by some standard. So Indian standard, now within Indian standard, these are the different code names like 8085, 3589. Okay, next IS you can say like 3130. Okay, so these are the all different codes adopted by Indian standard for manufacturing or for designing different mechanical components. Okay, codes tell the engineer what to do and when and what circumstances to do it. Standards tell the engineer how to do it. So that is also important thing is that code will basically tell you how you can go for it, how you can design. Okay, how you can manufacture and what time you can manufacture, that the actual design sequentially how we can design, so sequentially how we can manufacture. So this step by step sequence, this how this what to do or at what circumstances we can do. So these things are actually told by the code, whereas the standard can tell you that how you can do it. How means what is the standard procedure, whether it should be manufactured by casting or it should be manufactured by grinding. Okay, or it should be manufactured by cold working or hot working. So everything, the manufacturing process or how you are going to manufacture, so that will be basically specified by this term standard. Okay, so these 2 points are basically standard important when you are asked to distinguish between the code and standard. Okay, next, some design standards fall in 3 categories. Like, so we have 3 different categories by which we can identify the design standard. First of all, this is the performance standard. Next is the test method standard. Next is the codes of practice. So these are the three different criteria of design standardizations. So these are published performance standards for many products such as seat belt, lumbar, auto, crash safety, like this. Test method standards are like measuring the yield strength or thermal conductivity. So test standard means basically you are going to test some mechanical properties of any material like yield property, yield strength, ultimate tensile strength, fracture point, okay, the limiting point. So all are the different points, like we are conducting our experiment in the UTM, okay, universal testing machine, by which we can get some load versus deflection curve, okay, or stress strain curve. So this test method actually guides you that how you can measure the different points of failure, or how you can measure the different parameters or different variables of any mechanical component of or any item. Like you are measuring the thermal conductivity, okay, you are measuring the electrical conductivity, you are measuring the coefficient of thermal expansion, so you are measuring the calorimetry, okay, you are measuring the different flash point, okay, different burning points. So everything all come under the test method standard, okay. Next come to the code of practice. So that will give you the idea about the detailed design method for repetitive technical problems. So any technical problem, like you are you have manufactured any car is manufactured at the industry, okay, any like after manufacturing what happened, so every company certainly give you some warranty period or any guarantee period, okay. So within that warranty period, if vehicle has some problem, so it will be definitely rectified by the manufacturer itself. But after, as the warranty period vanishes or expires, so you have to produce your own money, you have to invest your own money for the repairing purpose or for the maintenance purpose. Now what happened, that you are suppose experiencing one problem in any vehicle, so you have rectified that problem. After 2 months the same problem appears, after 3 months the same problem appears, so this same problem repeatedly comes down. So the code should be made in such a way, such repeated problems, such defined problem, but it is coming in a repetitive manner, should be rectified by the procedure of adopting some codes which are coming in the practice, okay. So this is called the codes of practice, which is basically required to solve any repetitive error. Those test methods are developed by American Society. These terms you have to remember, like ASTM code. What is the full form of ASTM? American Society for Testing of Materials. And Underwriters Laboratory, like UL, okay. UL is basically a firefighting standard, okay. Underwriters Laboratory. Consider the design of boiler and pressure vessel code. These are developed by American Society of Mechanical Engineers, ASME, to regulate the machinery that has been adopted by all the states, okay. So ASME, the full form is American Society for Mechanical Engineers, okay. Now many of the standards are developed by the American Nuclear Society and the Society of Automotive Engineers, okay. So these are all the different American codes, international codes. National and other standards. Some standards are often prepared by individual companies for their own proprietary use. The next level of standard preparation involves group of companies in the same industry, okay. Like Reliance is the giant company, okay. So under Reliance umbrella, so you can see there are total 50 or 60 types of different industrial companies. So under this category they have followed certain code of conduct. So these code of conducts are very much applicable to all the subsidiary companies of Reliance Industries, okay, Reliance Industries. So these are the codes of conduct that are followed by the Reliance, but that should not be proposed by the Tata or any Adani or any other organizations like government PSUs, okay. So these are the code of standard that is absolutely defined by the company itself, that may not be applicable for any third party company, okay. Now industry standards of this type are usually submitted to the American National Standard Institute, like ANSI, for review, approval and publication, okay. Next is the ISO, that is International Organization for Standardization, that is the international code, and if any particular product is manufactured or designed with respect to this code, so it should be accepted globally, because it is the international standard and it is the standard for international organizations, okay. Now government specification standards, like engineers working in defense must have knowledge in the master incident list, like MIL. any particular person, if he is working in a government industry or any defense industry, so he must be aware about the term like master incident list. So this is the standard that is proposed by the defense organizations. Okay, so they have their different criteria for designing, okay, for the defense purpose. In the area of machine design, the following categorized items are standardized, like rules of preparing the drawings and use of the symbol. Like we have already come to know that what are the different welding symbols. For example, welding symbols. Okay, so these welding symbols are absolutely standardized and you cannot change that. Okay, so how you can put those symbols in engineering drawing, so that is also standardized. Fit tolerance for various parts from assembly considerations, dimension preferred sizes for various machine components, namely rivet, bolt, nut, key, bearing, so on. Okay, so these are all the mechanical components, and how you can go for designing all those mechanical components, these are absolutely standardized. Like in the ACDL lab, I have already told you the design procedure for map coupling, okay, for the knuckle joint, quarter joint. So all those dimensions are absolutely standardized as per certain codes, so you cannot change that. So likewise, thus all the engineering mechanical components, automobile components, electrical items are already in the design procedure, so they are manufactured as per some design guidelines or manufacturing guidelines, so you cannot violate that. Okay, now come to the benefits of standardization in design. So these occur in 4 stages, like cost reduction. I have already told you that is cost reduction and time reduction. Okay, so cost reduction means reduction in part number, large saving in procurement cost, reduce the cost through raw material standardization, reduction of inventory, floor space requirement. Now this term inventory, as you are in the diploma, so you do not have perhaps you do not have any idea about the inventory, but inventory is a very much important item in the factories or in the industries. So inventory means it is a just likewise a big collection of big buffer stock. Okay, so in the emergency purpose, if there is any shortage in the material, raw material, or maybe in the finished product, so that part already can be taken care or catered by the inventories. Okay, so this inventory cost is huge for any factory. So if you adopt some standardization procedure, so your inventory carrying cost, inventory overhead cost can be gradually reduced. Okay, next is the quality improvement. So you as a manufacturer, as a designer, must give some stress or must give some very much priority on the quality of the product, so that it should be widely accepted by the customers. Okay, next, production flexibility. So reliable delivery, flexible manufacturing, like this. Manufacturing responsiveness means parts availability, financially strong suppliers. Okay, so these are the all benefits of designing in the standardization or in the designing. The use of standard components and material lead to the cost reduction in many ways. It saves time when involved in original design work from spending time in finding the solution to identical problems. Design based on standard provide a basis for better understanding between the buyer and seller of the product. Mass production of the component at low cost, easy availability of parts at replacement and maintenance, less time and effort required for manufacture. The reduction in variations in size and grades of product by standardization on the more frequently used design features, simplifications and cost saving in tooling can be achieved. So these are all very much understandable to you all. So once you are asked in semester question or in the viva about the standardization benefit, so all those points you can arrange as per your own language or own thought. Okay, so you can use your own words. Next, come to the very important part, that is a design data book. Okay, machine design data book. So as it is included in your diploma syllabus, so I am just giving you in brief idea about the design data book and how you can use that. The machine design, a very interesting subject, required a basis of understanding which is provided by the basic knowledge of mechanical design and its application using the proper steps of design data book. First thing is that, so what is told that in the design book you get some idea about the machine design procedure and its applications, like whatever the materials you can go for, you can select whatever the materials to design, to manufacture any mechanical item. what are the design methodologies, what are the different applications. So all those items you can get the collected from the design data book. First thing is that we must know the initial formulas like power, torque, speed, etc., and its proper use for machine static and dynamic conditions. Okay, so under dynamic and static conditions we are all aware about the torque, power, speed, okay, the stability, all those items. So very much aware about the engineering mechanics. So it is the first criteria in any design data book that you should be very much aware of these basic engineering terms. Okay, in first part, design data book helps to give idea about the various formulas based on the physical parameter. So the first part basically contains the formulas on the physical parameters. Okay, physical parameters may be likewise different types of physical parameters. Okay, velocity, like any accelerations. Okay, so these are all the different physical parameters. So you should have the complete idea about the physical parameters. The basic formulas should be written at the very first part of the design data book. Okay, it may contain some dimensions which was also called the design variables. In second part, so it gives the detailed idea about the properties of various material used in the design. So the material properties will be specified in the second part, like for example material strength, material density, specific gravity, elastic constant. So these are the material properties and should be present in the second part of the design data book. Okay, next, BHN numbers along with its practical applications in mechanical field, etc. For next part, come to the next part, that is the third part. So in the third part, what would be written? So it contain various design steps for individual parts of any machine, like design of belt, clutch, brake, gear, bearing, roller chains, wire rope, etc., along with its various material properties. Okay, so the fourth part basically not fourth, is the third part. So the third part will contain the various design guidelines for various mechanical and automobile components, and along with their material, the material selectors. So material properties may the miscellaneous material properties may be provided in the third part of the design book. This part also contains the various feasible ranges of dimensions under which any part can be designed or redesigned within safety limit. Now in the map coupling, as you know, in the map coupling or in the cotter joint, knuckle joint, so once you get the diameter of the rod or diameter of the shaft, so rest of the part of the cotter you can easily calculate by some useful mathematical formulas like 1.5D, 2.5D. Now where from these data are coming? So these data are coming basically from the data handbook, and these are actually present at the third part of this particular design data book. Now next come to the last part. So last part in the data book, that is the appendix part. So it gives the idea about the various standard values for sizes like diameter, length, width, etc. in the common design specifications or common design sections. If you follow the data book by linking the formula, design parameters in stepwise manner, then that will be very helpful for design engineer in learning and its practical applications. So you can understand that this particular design data book contains various collection of informations like whatever the material you opt, okay, whatever the design guideline, what should be the design data, like what should be the diameter, what should be the different properties may come specific gravity, like thermal conductivity, okay, it's like different strength, mechanical strength, electrical properties, all should be written in the design data book. Now in which chapter or in which part of the data book it should be written, so that is completely guided by. Okay, so these are all about those things. So these are the two references by which I can get some idea, or I have gathered the informations. So you can also look at these two references. Okay, so these are all about my today's class. So that part standardization very easy to understand, just go through that and you can use your own word to express your thought in the question as a answer in against the question that may come in the semester. Okay, so this is very useful content, you can read it. So I want to complete my today's lecture like it at this moment. Okay, so thank you all.